Hi there, this is Algebra 1, and we are going to be doing lessons 37 through 40 today. So here's the deal. About 3 concepts that we're looking at in these 4 lessons. I'll start with lesson 37. If you all remember, if you have a number like 3 equals 2 plus 1, this is called an equation. It comes from the idea of equal. This side is equal to that side. Whenever you have an equal sign, what you're saying is it is true that this side equals that side. So even if you have an equation, something like 3 equals 2 plus x, this is still an equation, then you typically are looking for what makes this true. And that's if x equals 1. And so when we say solve, what we are saying is what makes it true. In other words, what x is going to work? Well, x equals 1. Okay, so this is the equation. Okay, there are 90% of the time in math you deal with this, but there's 10% of the time where it gets a little bit different, where you're not looking for what makes it equal, you're just looking for what makes it true. And so let me explain that a little bit. And this is lesson 37. It calls these things inequalities. Okay, an inequality, in means not equal. So there's something else going on, that it's not exactly equal. So for example, 4 is greater than 3. Okay, that's called an inequality. They're not equal, this is greater. Or you can say that 4 is greater than or equal to 2. Okay, that is also true. So what you're looking for in an inequality is you're still looking for true. And then if you throw variables in, you're asking for what makes it true. So for example, 5 is greater than or equal to 3 plus x. And so you're saying, okay, what is going to make this true? Well, anything 2 or smaller will make this true, because 3 plus 2 is 5, and 5 is greater than or equal to 5. So anything 2 or smaller, anything smaller than 2, like if it was 1 or a fraction or a negative number even, this is going to be true. So we would say in solving one of these, x has got to be less than or equal to 2. So in an inequality, the answers are typically going to be in less than or equal, greater than or equal. So those are going to be what makes it an inequality. So rather than saying what is it equal, you're saying what is it greater than or less. You also notice this is kind of easy. If you said 5 equals 3 plus 2, notice x is 2. So the math on it isn't any more complicated. It's just keeping track of what's going on here. That is the tricky part. Now, visually, what we do is we say, how do we represent this on a number line? Well, make your number line of 0, 1, 2, 3, 4, and negative numbers, -1, -2, -3, etc. And you say, okay, what does this look like on a number line? Well, you would say a couple of ways to do it. You would say it's a solid dot with a line to the left. That's what's going to make it true. Or better yet, let me just throw a different color on you. Pink. So it would be red. Well, that almost worked. Anyway, never mind that. There we go. Blue. Well, that didn't work either. But that's okay. We don't care. We're going to stick with that. So let's look at what you might have to do for homework to start with. And as I said, there's a couple of ways to represent these. One of them is to show it as a number line. Another one is to show it as a basic equation. So here's an example. It says, this is practice problem A. It says, draw a number line where x is less than or equal to 5. Okay, draw a number line. You make it as big as you need to. I'll put 0 down here. 1, 2, 3, 4, 5. Notice I don't really even need negative numbers. If you have colored pencils, which we're going to try and see if I can make that work. Okay, and it's going to be yeah, it actually did. That's kind of blue. And a solid line, and it's an arrow going to the left. Okay, now if I said, let's try problem B where x is less than 3, for example, and said, okay, I'm going to draw a number line. Draw a number line. 1, 2, 3, 4, 5, 6. Okay, let's make this 0. So that's 1, 2, 3, 4. Okay, so instead, what I'm going to try and do is I show this as an open dot. Let's see if I can make it red on this thing. There we go. I think that'll work. An open dot with a line to the left. So if it is less than, but there's no equal sign, it's an open dot. If it's less than or equal to, you make it a closed dot. Okay, that's the difference when you show it on a number line. That's pretty much lesson 37. Congratulations, you're now done. All right, let's go on to lesson number 38. All right, lesson 38. This is something we've done in class. It is called ratio problems. Well, ratio problems just means fractions or comparisons. So if I were to look at a problem and I would say, okay, the ratio of pencils to pens is 5 to 2. In other words, there's 5 pencils for every 2 pens. I could write that as 5 to 2 as a fraction. So the 2 becomes the fraction bar. The first one is the numerator typically, and the second one is the denominator. So you say the first one, again, numerator, second one, denominator. Okay, so that's how we would say it. Now, other than that, what this lesson is talking about primarily is just, do you know how to do fractions? And we've covered quite a bit as far as being able to see things. So they will say something like solve 4 over m equals 21 to 5. So in a word problem, you might say, well, you're just saying the top to the bottom, 4 to m is equal to 21 to 5. Okay, and in other words, because it's an equation sign, you're just saying what makes this true. Okay, so let's look, and it's going to be not necessarily a pretty number, but we'll see what it is. I'm going to show you whenever you have a fraction equals a fraction. I'm going to repeat this thing. Most people don't deal with the math part of it. In other words, the algebra part of it using the math rules. They use what's called the remove swap method. Okay, I'm going to explain the move swap method, and then I'll verify that, yes, it is indeed a true method. In a move swap method, if you have a fraction equals a fraction, you can take anything that's down here and move it to the opposite. Or anything up here, move it down there. Or you could have, again, fraction equals fraction. You could have something, whatever's here, move it up there. Whatever's here, move it up there. Whatever's here, move it down there. Now, you can even do more than one. So let's say, pick a simple fraction. 1/2 equals 5/10. You know that's true. And let's see if it works. If I move the 10 up to here, this becomes 10. Okay, and what I mean by that is when I say go up to there, I'm multiplying whatever was here, was a 1 first, times that. So, and then whatever's here, when I move something, I replace it with a 1. Okay, well, does 10 over 2 equal 5 over 1? Yes, it does. Okay, so let's try another one. So let's, again, 1/2 equals 5/10. I can also swap them, or sorry, I can move them another way. So let's say I move the 5 this way. This becomes a 5 times 2, and when you move something, you replace it with a 1. So 1 over 5 times 2, which is 10, equals 1/10. So moving is a valid way to help you solve these problems. And we can also, what we call, swap them. Again, I've covered this before, but I just want to make this really clear. So let's say if a fraction equals a fraction, I can take whatever's here, and just exchange them. So go back to my 1/2 equals 5/10. What if I swap them? Well, that's going to show as 1/5 equals 2/10. See, I just swapped the 2 and the 5, and that's also true. Swapping makes it true. Moving makes them true. Remember, when you move it, you're actually multiplying it, and then when it's gone, you leave it as a 1. All right, so let's take a look at this practice problem and just do it using move swap method up here. Okay, we've got, I want to find m. So I'm just going to make m by itself. The easiest way to do that is to move the m up here, or swap these two, and move the 5. So if I did that, I'm going to get m over here, okay, and the 21 down there, okay, and I'm going to move the 5 over here, and again replace it with a 1, so I end up with m by itself. Well, m equals 20 over 21. That's the answer. So all I did was move things around here and swap things, and I'm good to go. All right, let me give you another one. So let's say you have 7/5 equals 91 over, pick a letter, B. Okay, I want B. So I'm going to swap these two. Okay, and I'm going to leave the 91 where it is, and I'm going to move the 5 up here, and that's going to be my answer. 91 times, ooh, that was weird. 9 times 5 is 45, so 91 times 5 is 455 over 7. Answer. And if you did the math on that, that's actually equal to 65. But I'd calculator that one. So that's how you do it. Move and swap, get the letter by itself, and you're at the answer. That's pretty much lesson number 38. Now, let me give you that in a slightly different way, is put it in word problems, which is how you would actually use this. You know, it's like, okay, good, I can move things around in an equation. Yes, that's a skill you need to do. Now, why? So practice problem A, for example, it says the ratio of neophytes to masters, or neophytes to masters. Neophyte is somebody who's brand new, is equal to 7 to 2. Okay, there were 714 neophytes, so I'm not going to use that. I'm just going to use 714 neophytes. The question is, how many masters? Well, notice I have, if a ratio is equal to something, I know what all the things are except for one of the pieces. So I'm going to swap these two. I'm going to move the 2 again. What's that? So, and that becomes a 1. So masters equals 714 times 2. 700 times 2 is 1400. 2 times 14 is 28. So 1428 over 7. And I think that can be reduced. Yeah, it can. And that's 48. Again, I would expect you to do a calculator for probably these parts. Okay. That is lesson number 38. Lesson 39 is kind of advanced ratio problems. And when I say advanced ratio problems, it just means there's kind of one more little step in here. So I'll give you an example. This is lesson 39. So for example, you have the ratio of red marbles to blue marbles is 5 to 7. Okay? And it says there's a total of 156 marbles. Okay? So, I don't know how many red. I don't know how many blue. So how do I do this one? Well, if I look at this, I can kind of think of it this way. Red to blue is 5 to 7. Red to the total would be 5 out of 12, right? So if I think of it this way, there's 5 red to every 7 blue, or there's 5 red to every 12 total. So basically, you just have to add these up to get the total. Now, if I look at this one, well, I know there is 156. So red to 156 is equal to 5 to 12. Now, again, simple move and swap to get the answers here. So I'm going to move the 156 here. This becomes a 1, and I get red equals whatever that is, 5 times 156 over 12. And I take a calculator and solve that one. That's going to be 5 times 100 is 500. So 5 times 50 is 750. So, and then 5 times 6, so 780 over 12. And then do my calculator, man, and I know that 12 times something goes, anyway, and you get the answer. Use your calculator. That's why God made them. And so, that's kind of the first one. There is an example of that. I'll do practice problem A on lesson number 39 to show you how to do that. Practice problem A is going to be this. It says a team played 65 games. So 65 games. So I usually just write these out. Okay, the ratio of wins to losses, so W to L, was 3 to 2. Okay, the question is, how many wins? Well, I have two things. So instead of saying wins to losses is 3 to 2, I'm going to write wins to the total is 3 out of 5. Again, 3 wins or every 2 losses, so that means 3 wins out of every 5 total games. And if I know that the total actual games is 65, then that's my equation. Using my move swap, I'm going to move the 65 over, and I get 3 times 65 and 5. And again, I replace, when I move this over, I replace it with a 1. And the 1 I just leave off the fraction. And then 3 times 6 is 18. 3 times 5 is 15, so that's 195 over 5. And 195 over 5 is 39. Okay, and that's that. So one other little concept on lesson number 39. If you remember lesson 38, it was all about inequalities. What if something is not true? So this is how you would write this, just so in case you've never seen one of these before. You could say something like 5 is greater than 8. Okay, that is not true. Okay, so this is not true. So how you would show that is a line through it. So 5 is not greater than 8. Great, that means that 5 has to be less than or equal to 8. So if you see a not equal, you kind of look at what's opposite of this thing. So if I said, for example, 10 is less than or equal to 4, that's not true. So actually so that's not true. So what is actually true, what's the opposite of this one? That's 10 is greater than 4. So I kind of take less than or equal. What's opposite of less than or equal? Well, that's greater than. Because there's only 2 choices. You can either be less than, equal, or greater than. So less than is not good, equal is not good. What's left? Greater than. Greater than is not good, so what's left? Less than and equal. So if you think of it that way, you will be able to do much, much better on your math process. And so you might show a question, for example, practice problem C. It says draw a number line and show what x is greater than or equal to 2 not. Okay, well, this means x has got to be, well, it's not greater than, it's not equal, that means it has to be less than equal to 2. So turn this into this, and just draw your number line. 0, 1, 2, 3, and we'll go with red. And so it's less than, so it's an open circle, and an arrow off to the left. Okay, and that is how you would show it. So you can't really graph this. What you do is you turn it into that, and then you graph it. And that is lesson 39. Last lesson of the day has nothing to do with any of this stuff, although you'll have some practice on this stuff. And oops. Okay, I'm fine. Reset. Make this black. Okay, so lesson 40 is going to be about exponents. So if you remember something like x to the 4th times x to the 6th, well, that's x to the 10th. The rule is you just add them, because this is 4x's times 6x's. So that's, you end up with 10x's. So you're saying this times that, oh, so that times that, and well, that's so in other words, you can just add those. Okay, in the same way, even if you had x to the 4th over x by itself, if I were to write this, it's x over x. So what's the answer? Those cancel. I end up with x to the 3rd. So in this case, think of this as a 1. I can take the top minus the bottom, and I get x to the 4 minus 1 is 3. And so I could write this one as x to the 4th times x to the minus 1. Isn't that true? Yeah, 1 over x is this. Remember, fractions. 1 over 7 to the 3rd is the same as 7 to the negative 3rd. So negative exponents means you put it on the other side and make it positive. And vice versa, if it's negative, so if I have 1 over 7 to the negative 3rd, that's equal to 7 to the 3rd. Again, to make this positive, I just move it to the other side of the fraction. So, well, again, using the rule, well, what's 4 plus 6? 10. What's 4 plus negative 1? 3. So this rule works even if there's negative exponents. So that's what you're looking at on this problem, is just making sure you know that negative exponents follow the same rules as positive exponents do. In a practical sense, there's people do it different way. So I'll give you an example of what you might have to do on your homework. So you might have something as, x to the negative 6, y to the 4th, z to the 5th over x to the negative, sorry about that, messed it up. Reset, there we go, reset, there we go, cancel. X to the negative 6, forget that, times y to the 5th, z to the 2nd. Okay, so in this case, again, ignoring this piece, is x to the 6 over x to the 6. Well, that's just 1. Anything over itself is 1. Y to the 4th over y to the 5th. Well, what's 4 minus 5? That's negative 1. And what's z to the 5 over z to the 2nd? That's z to the 3rd. 5 minus 2 is 3. So you take the top minus the bottom, and you get the answer. And your y to the minus 1 becomes just y. And you have z to the 3rd. So you can take a complicated one like this and simplify it to this one, and only have positive exponents. Typically, your goal is to have either all positive exponents or just all of them along the top. So let's do one where in your homework it says make them just everything in the numerator like that. So here's one: m to the 4th, p to the 3rd, z to the 10th, d over m to the negative 2, p to the 4th, z to the negative 6, and d to the negative 2. So again, in a fraction, you just take top minus the bottom. So look at the m's. What's 4 minus a minus 2? Well, that's 6. That's that one. This one. What's 3 minus 4? That would be negative 1. Look at this one. What's 10 minus a minus 6? That's 16. And then this one, d, or d to the 1th. What's 1 minus a minus 2? That's d to the 3rd. That's the answer. Everything's in the numerator. You've eliminated the fraction, and you're done. So that's what you'll have in this homework. One more example, again, from your practice problem, where you have to do some distributive property stuff first, then you do it. So here's the example. This is practice problem C. Z to the negative 3rd over m, x to the 4th over m squared minus 3z over m. And what they're saying is use the distributive property and write everything in the numerator. So this is going to be a couple of steps. Now, again, remember distributive property, 3 times 2 plus 1. That's equal 3 times 2, 6, plus 3 times 1 is 3. Okay, so that's using the distributive property. All right, so let's look at this one. So this times this, I'm going to have z negative 3 x to the 4th over m times m squared, m to the 3rd, minus this times this. Okay, so that's z3, z to the negative 3 over m times m, which is m squared. Okay, so and then the answers are all in the numerator, so I'm going to rewrite this one as z to the minus 3x to the 4th, m to the negative 3, minus 3, this is z to the minus 2, because z to the 1th, again, 1 plus negative 3 is negative 2, m to the negative 2. And that's the answer. If you wanted them all in the numerator, in other words, not fractions. That's lesson 40. So I will see you when we return in January.